At Catalyst, free and open source isn't just what we do, it's what we stand for. So when we built the Catalyst Cloud, New Zealand's first fully API-driven public cloud, we naturally chose OpenStack. As well as free and open source software, we wanted to use open hardware as well. The Open Compute project grew out of Facebook sharing the designs for the vast server farms, some of the most energy-efficient and scalable data centers. The project designs commodity hardware that's more efficient, flexible and scalable than traditional proprietary hardware. John Laban is the European representative for the Open Compute Project Foundation. He's been designing or consulting on data centers for most of his career. In this presentation, he highlights the sea change that's happening in infrastructure as a service and the way Open Compute is upending the IT industry. If you're thinking about your organization's strategic direction in the compute space, this 30-minute presentation will be an invaluable introduction to what the future holds. John Laban was Catalyst's guest in March 2017.
Well, this is me. I only work part-time for the Open Compute Project Foundation. I started last June. I was just blown away when I did some consultancy work for Facebook in Luleå in northern Sweden. And I've been in the data center industry for a while. I used to own a company that designed and built data centers. And I saw the end of that business like 8 years ago when I sold my business. And enterprise data centers are just disappearing. If you go back to the beginning of, say, this decade, probably 80% of all equipment cabinets in the world were in data centers with less than 50 racks. Just going forward to, say, 2025 is probably going to be that 80% of all the equipment cabinets are going to be in data centers. They're going to be bigger than 120 racks. Those smaller data centers are all going. They're just disappearing. So it's not good business to be in. It's a good business to be in cloud services because those small enterprises are just pushing out their business into this space. There's some very good books to read if you're interested, and one very good book about the future of enterprise data centers is a book called, and it's all in this material, is a book called The Big Switch. And it's this guy, Nicholas Carr, makes an analogy between the utility of power. And he just looks at compute as being a utility like power. Who has a generator in their building doing base utility? You might have a generator for backup utility, but not base utility. And he makes this lovely analogy of what went before and what's happening now with the utility of compute. So very exciting times, lots of opportunities, and mainly for the small and the agile. I'll show you some of the big companies who are really struggling. They can't turn around. They're going into a brick wall. And it's really exciting. That means there's lots of opportunities, business opportunities for small companies like this. I was surprised how big you are as a company. I didn't realize that you over 200 people, which is a large company in this neck of the woods. Perhaps not in London, but in this neck of the woods. But you're focused on the openness. This is another thing that's changing towards the openness. That's thanking you guys for being here. As I say, I discovered this when I went up to Luleå, to this Facebook data center, and I just was blown away. Absolutely blown away. And I just want to show you some of the things that I was blown away by. I thought I was a good data center designer, but I realized I spent 20 years wasting my customers' money. And seriously, it really is quite shocking what we used to do. Now, this is what the Open Compute Project Foundation is. It's a not-for-profit foundation. It was started as a consequence of Facebook, who developed their own server solutions, their own hardware solutions, storage solutions as well. And they just said, well, let's open source them. Now, you can argue that they did it because if they open source the hardware and they get higher volumes, then their costs come down on the unit buy price. So that's my cynical view on it, but that's really what happened in 2011. Now, what's interesting, if you look at the adoption of open compute hardware, it's following a very, very similar track to the Linux Foundation, which started in 2010. And if you look at the growth of Linux into data centers since 2010, today it's not 90% of every server in the data center is Linux. Yeah? Track that with what's happening on the OCP, and you'll see this kind of by 2025, this more than 80% is following a very similar trajectory. And it's really interesting how it's all tied into OpenStack, because directly you go into OpenStack, you commoditize the hardware. It's just what happens. So if I'm trying to find anybody that's interested in commoditized hardware, low-cost hardware, vanity-free hardware, I just go and find who's adopting OpenStack. And in the UK at the moment, that growth is, I think it's 50-odd% per annum growth. It's really rapid. I don't know what the growth is here, but it's just grown so quickly. And that, following that, and you can track underneath it, the growth in the commoditized hardware. So it's a very exciting time. But you'll have less time to go out doing motorcycling, because I think you've got a motorbike, if I remember right, because I read about you in your website. Now, I'm going to use a series of cartoons in this, but what this is trying to represent is the idea of simplicity. One thing that's really key to the whole of the design of this hardware is this obsession with simplicity. Okay? It really is simple. I'll give you an example. If you took, say, the Facebook infrastructure, they've got millions of servers in over 100,000 racks, yet they only have 7 rack configurations. They only have 7 rack configurations. Go into a typical enterprise data center or a telephone exchange, every rack will be infinitely different. There's an infinite number of racks. So simplicity is really fundamental to the way this works. This is why when you run OCP at scale, the technician to physical server node ratio in an OCP data center at scale is 1 technician to 25,000 physical servers. It's huge. It's hugely efficient. If you come into an enterprise like a big bank in New Zealand, they might achieve 1 technician to 250 servers. That means there's 100 times less people in these optimized solutions. And part of it is the obsession with simplicity. You don't go to the back of an OCP rack. You service it all from the front. That makes a big difference. I'll show you some of the things they've applied. They've reinvented the way it's done. So simplicity is really key. Now I'm going to give you these slides, the PowerPoint slides, and I would love you to watch some of these videos. This is Frank Fakowski, and Frank is one of the founding members, and he tells this lovely story about openness always winning. Okay? And I think you'll find it very inspirational. And I'm totally convinced that openness will win in the end, and all the proprietary systems will just die. I always put a little comical one on the front when I'm going to tell a bit of a bad story with a table, because the next slide, this here is a proprietary hardware vendor. And this is what happened to their share price in 2016, just collapsed. Here is an open source hardware vendor. And their share price went up by a factor of 6, roughly the same time. And if you track the proprietary vendors against these vendors that you've never heard of, by the way, the manufacturers, who's heard of WeWin? WeWin, so few people, WeWin. Who's heard of Acton? Acton. These companies are huge. Who's heard of QCT? QCT. Do you know that QCT, within about a year and a half, will have a higher turnover, higher sales turnover than Cisco? And most people never heard of them. The brand was only developed 2.5 years ago. They make 1 in 7 of every server that goes into a data center. They make about 30% of the world's laptops, and you never heard of them. Now, this is what's happening because these vendors that you know and love, all the big brands, they didn't really make the stuff anyway. They just outsourced it. And what the big hyperscaler says is, well, let's value engineer the product, make it vanity free, take the rubbish out that we don't need, but don't buy it through you. I'm going to go to the guy who makes it. And this is what happened. So in a way, OCP started as a bit of a buyer's club. How can we cut out the middleman who's locking us in and we don't want him involved in it anymore? Okay, that's really what happened. So this is quite profound. Just go on the Bloomberg share prices, go onto the OCP website, look at all the members, all the big members that are there, companies you've never heard of. Go and look at their share prices and then look at the other boys. Brocade's just been sold. So all this proprietary stuff is really kind of, they're in trouble. And it's thanks to you people who are pushing the open side that's really making the difference. Now what's happening, you can actually detect this in other ways. This here is called a patent pool. And all these companies that are kind of, they see the end of their proprietary equipment, they're setting up these patent pools to kind of slow down this innovation. But it's really funny, like companies like Canonical, especially on the hardware, on the mobile phone systems, Canonical were being hindered by some of the restrictive patents on the hardware. So they basically just wrote software so you don't need the hardware anymore. And this is really what's happening. They are not going to stop it, because if you've got a proprietary network function that's in a box, you can write the equivalent function in a Linux container as a network function virtualization. So they just can't stop it, but they're setting up these patent pools to try and, it's a kind of a sad thing, but it happens. Yeah. It's more than just what's happening in our industry. Tesla, there's no patents on Tesla cars. There are no patents. So if you look at any major innovation, disruptive innovation that's happening today, you'll find that they're outside, they're not following these patents conditions, the traditional route. And if you want to learn a bit more about it in a deeper way, then read this book. Just read that book, and you'll see the way, it's a book about the macroeconomics of collaborative commons and the end of patents and new ways of working. And it's a profound book. And you're not going to adopt all this, you're not going to kind of move forward until you believe. This is not a religious thing, but you know, if I'm trying to sell anything, I don't want to be going into non-believers. Yeah? I need to be sitting in front of somebody who believes in non-patents and the advantages of that kind of environment, and then it's a very easy sell. Very easy sell. So we touched on it as we were driving over, that the biggest hindrance that we've got, these technologies are mature. They've been used in the hyperscalers now since 2008. The big problem is people's mindsets. It's really disruptive. If I go into a chief information officer and I say to him, if you adopt in your big bank infrastructure, OCP infrastructures, you can reduce your staffing levels, the technicians in the data centers, by 80%. He doesn't want to hear that, because that's the end of him. So what's happening, there's a trend happening at the moment where they're basically, the chief financial officer is getting rid of the chief information officer, bringing in a change maker that does the transformation, and then that change maker, once they've done the transformation in a couple of years, they move on to do it again somewhere else, and then they bring in the kind of the routine chief information officer. But it's a very, very difficult sell. When you go in and you talk about all the efficiencies and the power efficiencies, the reductions in labour, staff in the environment, people get very, very angry. There are no UPSs, centralised UPSs in OCP data centres. It's just really funny what it's killed. I'll show you. Now, what I'm going to quickly show you here, imagine this. This is a traditional computer server rack, and in it, there's 40 servers. And up here, you've got top-of-rack switches, 1, 2, 3 top-of-rack switches. You've got 40 servers. Now, what I'm going to try and show you is the impact of OCP, what it takes away from a traditional server rack. Okay? Okay? Let me try and just show you, because this is where it's really radical. So the first thing that OCP does, an OCP equivalent with 40 servers in, 40 of these servers, it takes away initially 2 of the top-of-rack switches. Now, this is where it gets really interesting. If anybody wants to talk to me afterwards, the out-of-band management on these servers is done through the bus bar at the back. You don't do it as an Ethernet port on the front. So you don't need a top-of-rack Ethernet switch. All you have is you have a Raspberry Pi, which costs you $25, connected to the DC busbar on the back. It's kind of quite radical, but this is the way it is. But it's a huge saving. Next thing is, you don't have power supply units inside OCP gear. The AC to DC power supplies, you just take them out. Because when you plug in the OCP gear, it just pushes into a 12-volt busbar or a 48-volt DC busbar at the back of the rack. So you don't have them. Let me just take a few out. So these red things are the power supplies. Take them out of all the servers. Now, what I'm also taking out, these little yellow things here, these orange things, are 40mm diameter fans that you would get in a traditional one-use server. Okay? You don't have 40mm fans in OCP equipment. We use a different way of doing the cooling. I'll explain. So let's just take out a few of the things. So this is a traditional kind of system. So I've thrown away all that gear. Now what you've got at the back here, these green things are the intelligent power strips. They're the intelligent power strips. In an OCP rack, you don't have those either. You throw them away. Now just those 4 strips, to do 40 servers in a rack, I'm thrown away in excess, somewhere between $4,000 to $5,000 worth of gear that's unnecessary. Just on those 4 strips. That there is all the cabling spaghetti at the back of the rack, all the power cables, all the comms cables. That's at the back of the rack. Throw that away as well, because we don't interface on the back, we do it on the front, and we use a lot less cables. Another thing it does away, that thing there that I've just removed is the computer room air conditioning unit as a downflow crack unit. We don't have those in optimized OCP data centers because they're very, very inefficient. We take them out. There is no refrigeration cooling in an OCP data center. Just to get your head around the kind of the numbers on the energy savings, if I've got that crack unit in here, within it there's mechanical chilling. It's like a refrigeration unit. Directly you turn off the refrigeration cycle within a cooling system in a data center, it reduces the power for the cooling for the data center by up to 90%, because all those pumps are very energy inefficient. So it's hugely more efficient in an OCP data center. OCP data centers, for those that, I won't get into the technical detail, but the PUE on an OCP data center is about 1.1 or better. They're very, very efficient. And it impacts all sorts of things. So you don't need that. That goes away. Consequently, you don't have the cool air going under the access floor. That's an access floor there, filled with cables. Takes away that, because the way you do the cooling, that was all the cables that were under the floor. You throw those away, because there isn't an access floor in an OCP data center. You don't have an access floor. You can, but if you're designing from scratch, you don't. You take them out. You don't have them. And what's good about that, that's perfect for anywhere where there's seismic problems. If you've got seismic issues, I've spent 8 years designing data centers in Turkey, so I know a lot about seismic engineering, and one thing that you try and avoid right from the beginning, if you can, is you get rid of the access floor, okay? Because if you don't, you've got to do a lot of engineering. You've done a lot of engineering on the amount of engineering I've just seen their data center that they've had to do. If that access floor wasn't there, it could have saved a fortune, but they had it, so they had to engineer it. Now, what have I taken out? I've taken out this dross, I call it the dross. I've taken out the top-of-rack switches. I've taken out the pluggable optics, which are very expensive. I've taken out 86 power supply units. I've taken out 208 40mm fans. I've taken out 4 AC power strips. 86 IEC rear cords, you know the cords, the IEC kettle cords, taken all those out, throw them away. 86 of those, 120 RJ45 patch cords, which you don't need. Okay. I've taken out the crack units, I've taken out the access floors, and I've taken out that. Now that's just to do with that rack. That is a cost saving of around about up to $16,000. All right, so this is why this stuff, it's more than what you just see on that piece of kit. It's the impact it has on everything else. So for every rack in an OCP data center, you're looking at somewhere between $10,000 to $16,000 less for 40 server configuration. And that's before I get into the wider implications, like I don't need a centralized UPS. This is why this stuff is so cost effective. It kills all these things: centralized UPS, access floors, intelligent power strips, tools. OCP gear is toolless. If you look at that server, you'll see these green things on there. They're called green touch points. In order that it's an OCP server, it has to be toolless. You don't use tools. It's a condition of that's a condition. So it will not go through the accreditation procedures unless it's toolless. You do away with support technicians. You do away with complexity, hardware redundancy. You do away with low quality, because I'm a great believer, and I think the facts are starting to come out, that open source develops better quality products faster. Just does. And you do away with that nasty thing called lock-in, that proprietary lock-in on the hardware. Let me just take you through a few of the things that we did historically and how things are changing as a result. We used 19-inch racks because they held electromechanical relays. That's why they're called relay racks. What do we put into a rack today? We put these things in. You're all familiar with these. You've probably never seen any of these in a computer room. Electromechanical relay. But you've probably seen lots of these. Now, this is where it's quite subtle. The actual width of the vertical fixing rails on an OCP solution is slightly wider than 19-inch for a good reason. Various reasons. But one of them is to do with these hard drives. This is a standard hard disk drive. 1, 2, 3, 4, 5. These are 4 inches. You can get 5 of them across an OCP rail configuration. 5, but you can only get 4 across a 19-inch. Therefore, in the same volume of rack, you get 25% more hard drives. And all they've done, they've not made the rack any bigger, they've just moved the rails slightly wider. Consequently, the optimization of the volume, the physical volume inside a rack, is more than 15% more volume efficient. You're using up the space. There is a drawback to this. If you put that many hard drives into a rack, it weighs somewhere in the region of about 1.5 ton, okay? 1.5 ton. So there's a big issue trying to implement these OCP racks into conventional data centers, because most data centers can't accept 1.5 ton. This is just a little funny that you've got to laugh at yourself really about what we've been doing. And it just turns out that the 19-inch is the frame size that are used in Beehives. So perhaps it didn't come from the 19-inch relay rack. Perhaps it came as a medieval thing from Beehives years ago. I don't know. But again, one of my favourite cartoons. Lovely. Now, this human design makes sense. You've got the module, and then you make the egg box. We've been doing it the other way around for so long. We've got 19 inches, and we've been bending all this sheet metal to try and put a server into a 19-inch frame. Crazy. The OCP guys, they just said, no, we're not going to do it anymore, we're just going to change. So the width is slightly different on the rail, and the rack unit is slightly different as well, it's bigger. Okay? And I'll explain why. Now, you can look at these later. These are videos, 3-minute explainer videos. Luckily, you've got a unit there, but it's very difficult to actually see any of this stuff unless you've been into the big hyperscale data centers, and I don't think there's a single hyperscale data center in New Zealand that's used. I don't think there is. Australia, but not here. So go and have a look at these videos. Why did they change the kind of the rack unit dimension, and why did they do it? Now, it's just a basic bit of physics, and it's called the fan cube law. And the fan cube law is this. If you halve the speed of a fan, you reduce its power by 7/8. Got me? Halve the speed, reduce the power by 7/8. So therefore, If you use bigger fans and make them go a little bit slower, you get massive efficiency. Now, in a traditional server, you would have probably that many fans inside, plus have the fans inside the power supplies for the server as well. So in a typical one-use server, you might have about 8 fans, 40 millimetre. In an OCP server, you'll have 2 80 millimetre fans. Now, just trying to get your head around this, the energy required to push the air through with these 2 fans compared to all of these fans is 1/10 of the power. So just on fans is really quite dramatic. It reduces the energy just for the fans. And I've taken out 208 fans, haven't I? They all add up to a lot of energy. Another thing is why the rack unit is higher is because you can get bigger heat sinks on. The bigger the heat sink, the more effective it is for getting stuff off the CPU. So when you come and have a look at this later, just have a look at the size of the heat sinks. They're huge. But that allows you to cool them efficiently. Now, this is just a little story about why do we have the cabling interfaces on the back of a server. Because basically, what a server is, it's a desktop PC that someone put on a shelf and pushed in a rack. And then we just carried on that way. An OCP server does away with all that. It does away with all the power supplies, does away with the AC input into the server, does away with the out-of-band management, does away with all those miscellaneous operational ports, because when you truly are getting to scale on an OCP infrastructure, you only need 1 Ethernet port on the server, because you don't care if you lose the server. You just don't care. Because what OpenStack does, it virtualizes the instances across the resource, and you don't mind losing a rack, you just don't care. Therefore, you don't need hardware redundancy in the same way, because you're using software. When was the last time you plugged in a keyboard, a video, or a mouse inside in a rack? You just don't do it. So in an OCP server, they take all the graphics elements out. They just throw them away, don't need them. Even though you might not have something plugged into the graphics port, it's still consuming power. That graphics element inside is still consuming power. So why leave it in there? Take it out. And the only thing you basically have at the end, you have 1 Ethernet port on the front. This time it's on the front. There's nothing on the back. All you got on the back, when you push the server in, you just got a DC clip, and it clips onto the 12-volt DC supply. This is another thing, if we want to go and have a look, and it's a description about the rack and how it works, the powering. This is just a little bit more about the rack. This is quite interesting. You mentioned the idea of recycling and the use of materials. This is actually made out of banana skins. That's not why it's green. It's a green touch point. You lift it off. Why do we use access floors? Access floors because we used to run water pipes into the floor. This is a mainframe room. This is why we had access floors. And we just carried on doing it. Access floors are a problem in seismic. Why did we have tight control on temperature and humidity? Well, you know, if you've got high humidity and you've got printers, then the paper curls and they jam. We used to have people inside the room. These were called computer operators. They lived inside the room. This is the reason. It wasn't to do with the mainframe. The mainframe was water-cooled. We didn't care about the kind of air environment around it, providing it wasn't corrosive. We didn't care. It was to do with these things that we had in the rooms. But you don't have these things in equipment rooms anymore. And then once we started developing these 1U type servers, we had to have close control on temperature, because the way the cooling air travels through these 1U servers, these traditional ones, is so bad, you have to maintain a low temperature on the front. In an OCP server, you can achieve inlet temperatures on the front higher than 40 degrees centigrade. And it still works. Well, what that means is you don't need any refrigeration cooling anymore. Therefore, it's very efficient. And you've just got to have a look at how efficient the cooling's done on these. It's just very, very efficient. And here are all the fans. Can you see they've got all the arrays of fans here? Plus you've got fans in the power supplies as well. Now, this is a traditional data center. You've got centralized UPS, you've got chiller systems, OCP data center. You just take them out. You take out the chiller systems, Then you take out the centralised UPS, just throw them away. Don't need them anymore. And then what you do here, you have something called LES, Local Energy Store. So again, this is all very new. This has only been in the last 2 years. The earlier OCP solutions didn't do this, and it's all because of the enhancements in lithium-ion cell technology. Because lithium-ion, it's got much higher operating temperatures. You can't put a valve-regulated battery system inside a server rack because the temperature goes too high. With lithium-ion, they operate at 50 degrees. So what they're doing there, they're implanting the UPS function inside the rack. And you'll see that from the other videos, if you go and have a look at those YouTube videos. Just showing you a comparison between the two. All toolless, completely toolless. Now this is an interesting one. You have to get your head around this because we had a very interesting discussion about a power shelf that failed. Well, once you configure your OCP data center, you don't care about the failure. And it was very unusual. I've not known that to happen. But just read this. They don't care about the server, they don't care about the rack, and in fact, at the end, they don't even care about the data center. And I loved a little comment on there, is the rope necessary? And really, that's the philosophy of the design of these data centers. And it's holistic, it's the whole ecosystem of the data center. So by modifying the change in the server, has enormous impact on the whole data center. That 40 server rack I showed you in the beginning, if I just change that into 40 OCP servers, based on London electricity prices, the reduction in electricity cost per year on that 140 server rack is £5,000 less per rack. So if I've got a 100 rack data center, which is not very big, it's £500,000 a year electricity saving on a 100 rack data center. It's huge. And our electricity prices in the UK are going up 10% this year, so you can add a little bit more. Okay? So this is what's really key. And then you've got this trickle-down effect. The OTTs, the over-the-top hyperscalers started doing it. The telcos are going crazy to do it. You can actually put there, be finished by the end of the decade. And there it's coming into the enterprises and into the smaller cloud players. And this is why these smaller cloud players can match these prices of the big hyperscalers, because the cost reduction on the infrastructure is just so huge. Read that book. You don't have to kind of make a change. If you want to go into a kind of a steady decline and become extinct, you can do. Okay? This is a very good book. It's about mindsets, about ignoring the obvious at your peril. It's a very good book because remember, the adoption of this is it's up here. And where did I leave you? This is the Kubler-Ross curve. The Kubler-Ross curve is what happens when someone close to you dies. And this is your performance over time. So someone dies, you go into a state of shock, denial, get angry, you get depressed, then you get to an acceptance point that they may have died, and then you start to come back and start living again. And all I hope is that from this little session here, I've left you here. And that's all I'll leave it for now. But it is radical. It's very radical stuff. And that's it. There's loads more slides. That's it. Thanks for your time.
If you'd like to find out more about Open Compute and the Catalyst Cloud, visit cloud.catalyst.net.nz. The Catalyst Cloud offers a range of services built with enterprise capabilities that are the building blocks for your business and IT needs now and into the future John Laban just described. Catalyst, the freedom to innovate.